Hi, Dr. Tashan here, and in this video we are going to review solving linear inequalities and we're going to graph their solution. We're going to represent each of the answers as an inequality as well as the graph, and we're going to represent interval notation. Each of these notations is displayed over here on the board, but you will see those as we work through the examples. We'll work through 3 examples right now, and let's start with example number 1. Example number 1, we want to take 3 minus 2x is less than 5, and we want to solve for x. Similar strategy when you're solving equations, but here's how you would change it up to deal with inequalities. So we want to isolate the x on the left-hand side. Let's isolate the x. So we'll start by subtracting 3. In this example, let's subtract 3 from both sides of our inequality, okay? On the left-hand side, when you take 3 away, the 3's are gone, so you bring down the negative. Don't forget to bring the negative with the 2. So you bring down the negative and the 2x. On the right-hand side, what do we have here? 5 minus 3. 5 minus 3 is 2. All right, so here's our first step. What do we need to do next? Well, remember, we want to get the x by itself. We want to isolate the x. We don't want negative 2 times x. We just want x. So let's divide the left-hand side by negative 2. Divide the right-hand side by negative 2. Divide both sides by negative 2. Now, do we remember when you divide both sides of an inequality by a negative? When you divide by a negative, remember what we have to do. Okay, we have to switch that inequality sign, don't we? All right, do we know why we have to switch the inequality sign? Maybe we can talk about that really quick. Okay, let's look at a little scenario so you can see why. So here's a number line, negative infinity to positive infinity. So here's a number line. We're going to put some numbers on here. Let's put the 0 right here. Okay, all right, so maybe this is at 1 and this is 2 and 3 and 4. Okay, come on this side. So negative 1 and negative 2, negative 3, negative 4. I'll put negative 5 here, negative 6. Okay, so here's a few numbers on my number line. All right, so we've got a few numbers on my number line. The farther you move to the right, the bigger the numbers get. The farther we move to the left, the smaller the numbers get. Right? So any 2 numbers on the number line, as long as they're not the same thing, you can take any 2 numbers and put them in order. One of the numbers is going to be smaller than the other number. So let's take a look at a couple of numbers on this number line. Let's look at the negative 6. I'll just put negative 6, negative 2. Negative 6 is to the left of negative 2, so we can say negative 6 is less than negative 2. All right? We have 2 numbers. You can order any 2 numbers. You can take any 2 numbers in our number system. One is going to be bigger than the other. One's going to be smaller than the other. You can put them in order. All right, so this is an absolutely true statement. You see that, okay? This is a true statement. Now, what happens if we take both sides of this inequality and let's go ahead and divide by negative 2? Let's divide by negative and see what happens, okay? Let's see what happens. What is negative 6 divided by negative 2? Well, negative divided by negative is positive, so 6 divided by 2, so you get 3. Negative 6 divided by negative 2 is 3, okay? Let's go to the other side. What is negative 2 divided by a negative 2? Negative 2 divided by negative 2 is positive 1, okay? Now, what just happened here? We divided by a negative, and look what happened. Remember, any 2 numbers on our number system, we can put them in order. One's going to be larger than the other. So what do we have here, this statement here? Well, you know what? 3 is larger than 1, okay? So we started with the less than, we finished with the greater than. Anytime you divide both sides of an inequality, anytime you divide both sides, then you need to switch the sign. You can take any 2 numbers and put them in order. One will always be smaller than the other, all right? So what happens when you take those 2 numbers and you divide those 2 numbers by a negative? What happens is it switches the order. It just does. This is like a mathematical fact of life with number theory with numbers. So, so we need to preserve that behavior in our equations and inequalities. When we're solving inequalities with variables, we need to preserve this, okay? So when we divide both sides by a negative, all right, here the negative 2's cancel out, back to our problem, okay? But we're dividing by a negative, so we need to switch the inequality sign, make it greater than, and then divide 2 divided by negative 2, and you get negative 1. So here's your inequality answer. When you divide by a negative, you want to remember that you have to switch the inequality sign, because dividing 2 numbers by a negative number switches their order, okay? So take a look here, and then so our answer in interval notation is x is greater than -1. This is what your interval notation looks, or this is what your inequality, this is your inequality answer, okay? Let's graph this. So we're gonna grab a number line, we're gonna graph this, okay? So let's put, this is infinity to the right side, this is negative infinity over here, and we wanna go ahead and graph this. So -1, all right, so put -1 on our number line, and are we going to include the -1 or not to include the -1? Well, we have an inequality symbol that is strictly greater than, not equal to at all. It doesn't have the equal to notation. So strictly greater than or strictly less than, you use a parenthesis and not a bracket on your number line. So we want to indicate with a parenthesis that we're not including this, and we want the values of x greater than -1. So you're going to shade your number line, okay? You always shade where the values satisfy the inequality, okay? So we want to shade the values greater than -1, but we do not want to include -1. So we put a parenthesis, but your parenthesis needs to open in the direction that you shaded. So you put a parenthesis in the direction you shaded. Here's what your graph looks like. Now, how do we write our answer in interval notation? Well, once you have the graph, you could probably just read it off the graph. Where did we shade? Where did we shade? We shaded from -1, all right, to infinity, okay? So comma, infinity, that's where we shaded, okay? We're not including -1, so parenthesis, and infinity is not a number, it's a condition, so we never include infinity, so parenthesis around the infinity, all right? So here's your inequality. This is the inequality we had to solve. There's a lot of stuff going on in this inequality. Divide both sides by a negative, you've got to change the inequality sign, okay? Here's your inequality answer, graphing it, and then how we write it as an interval. All right, let's take a look at example number 2. Example number 2, -1 is less than 3x minus 5/2, which is less than 9. So we want to solve this. We want to isolate the x in the middle. We want the x by itself. So let's isolate the x in the middle. So how do we even begin? Well, we want to multiply by 2. Multiply by 2. Okay, so we'll get that fraction out of there, multiply. So whatever you do in the middle, you have to do to both these wings over here. So if you're going to multiply the middle by 2, then you got to multiply the left side and the right side by 2. Let's multiply by 2, get the fractions out of the way. So multiply by 2 over here gives us -2, okay? Multiply by 2 here, the 2's cancel, gives us 3x minus 5. And then multiply 9 times 2 is 18. Okay, so multiply all 3 parts by 2. Now we want to isolate the x. We want x by itself. So see where we need to go next? We need to add 5. Add 5 in the middle because we want to get the x by itself. Whatever we do to the middle, we have to do here, and we have to do here. So we're going to add 5. Add 5. All right. So you have -2 and a +5. That's 3. All right, is less than, in the middle here, the 5's cancel, so you just have the 3 times x, and then 18 plus 5 is 23. And so we have this. All right, now what? Well, let's see. We don't want 3 times x. We just want x by itself. We want the x by itself, so let's go ahead and divide by 3. Whatever we do in the middle, we're going to divide by 3, divide by 3. Okay? So on the left side, 3 divided by 3 is 1, is less than middle. The 3's cancel, we have x by itself, all right? Less than or equal to 23 thirds. I'll just call it 23 thirds. Here's our inequality answer. Now we divided by a positive number, so you don't have to switch the inequality sign when you divide by a positive number. So here's your inequality answer. Let's take a look at this on a graph. Now remember, we're on a number line. So our number line, we're going from negative infinities, okay, to positive infinity. There's our number line. Okay, let's put our numbers on here. So we'll put 1, 23 thirds. All right, so 23 divided by 3, it's 7 2/3, right? So that's, over here. So I'll call it 23 thirds. All right. And we want to shade all the x's that are larger than 1. Can you see this? The larger, 1 is less than the x's, larger than 1, but the x's that are less than 23/3. So we want to shade in between here. Okay, so this is where our shading is. All right. Now, we have to figure out, do we include these endpoints or do we not include? Well, that's based on the inequality system. It's simple. So if the inequality sign is strictly less than or strictly greater than, does not have the equal portion, we don't want to include it. So we use parenthesis. We do not want to include the 1, so you use a parenthesis to mark the endpoint, and the parenthesis needs to open in the direction you're shading. Okay. What about the 23/3? Okay. Well, this endpoint is inclusive. This is included because you have the equal to sign with the inequality. So we want to include, which means we're going to use a bracket to represent the 23/3, so we make sure we include it. But when you write your bracket notation, it has to open in the direction that you're shading. So you would write a bracket this way. Okay. And then finally, what about interval notation? Once you have your graph set up, the interval notation you should just be able to see it, jumps right out at you just by looking at the graph. Where did we shade? We shaded from 1, to 23/3. That's where we shaded, isn't it? Okay. And now the 1, we are not including the 1, but we are including the 23/3, and so we're here. Okay. So here is example number 2. All right. And over here on the screen with the notations for interval, inequality, and graph, you can see the parentheses with the brackets notated there. All right, so it's all displayed there with all the different scenarios. Let's take a look at example number 3. How do we want to approach example number 3? You do have some options here. There's more than one way you can approach this. I'm just going to go through one sample. So for me, when I'm solving equations and inequalities, I like to remove the grouping symbols first. So let's go ahead and start by distributing the -2 inside the parentheses. So -2 times -3 is a -6, okay? And then -2 times a -x, negative times negative is positive, so positive 2x, okay? And then on the right-hand side of this inequality, we have the 4. So we're here. So I'm going to start by removing the grouping symbols. Next, let's go ahead and we want to get the x by itself. Let's go ahead and add 6 to both sides. So we'll go ahead and add 6 to both sides. On the left-hand side, your 6's go away, so you just have 2x. All right. On the right-hand side, 4 plus 6, that's 10. All right, so that's 10. All right, we're working through it. 2x is less than or equal to 10. Well, we don't want 2x. We're solving our inequality for x. Let's divide both sides by 2. All right, so divide both sides by 2. 2's cancel on the left. You've got x by itself. All right, bring down the inequality symbol. 10 divided by 2 is 5. Okay. Now, don't change the inequality here because, again, we're not dividing by a negative. We're dividing by a positive number, so we're okay. It's when you divide by a negative that the order changes, right? But divide by a positive number, we're okay. So x is less than or equal to 5, and there is your there's your inequality answer. All right, take a look at the graph. Let's look at the graph. We want to graph this. Now, I'm going to graph it on a number line. Your number line runs from -infinity to positive infinity. All right, just write so it can show -infinity to positive infinity. 5 is our number, so let's put 5 somewhere on the number line. And we want to shade the x values. Can you see we want to shade the x values less than or equal to 5? Less than, so that's on this side. So we want to shade this side of where the 5 is, okay? So less than or equal to 5. All right, so we're shading this side. Now, are we including the 5 or are we not including the 5? Well, it is inclusive, isn't it? Less than or equal to, it is inclusive, so we use a bracket instead of a parenthesis. We're going to put a bracket on the 5, but we want to situate the bracket so the bracket opens in the direction that we shaded. We shaded this way, so we put the bracket this way. Okay, Okay, so here's what your graph looks like. Now, what about interval notation? Well, interval notation, once you have the graph, the interval expression should just kind of jump out at you. Look, so the interval expression needs to represent where we shaded. Where did we shade? Well, look where we shaded. Do you see we shaded between negative infinity, okay, because you want to put this down left to right, negative infinity to 5. All right, so this is where we shaded, okay? We can see that we are including the 5. We need a bracket on 5, but the infinities and negative infinities, you always use a parenthesis. We always use parentheses because it's, you know, infinity, negative infinity is, it's more of a condition. It's not a number, so it's not, you can't include something like that. All right, so here's how you would represent the answer in all your notations for number 3. All right, okay, so solving linear inequalities. I hope this was okay to review the concept for you. Thank you so much for watching. I appreciate it. Thank you again. Bye-bye.